Number 4, initially in a 3-liter container, there are 1.2 moles of NO2 and 0.96 moles of N2O4. We're going to find all equilibrium concentrations. We're given the reaction, we're given the K value. I've already written my equilibrium expression. Now, and when I wrote my equilibrium expression, since N2O4 has a coefficient of 1, it has an exponent of 1. NO2 has a coefficient of 2, so it has an exponent of 2, and I have products over reactants. Since it says initially, I know I'm going to need to use an ice chart because I'm being asked about both initial and equilibrium values. And what I need to plug into my table has to be molarities, and I've been given moles. So both of these moles values, I'm going to need to convert to molarity by dividing by 3 liters. So for NO2, I'm going to need to take 1.2 and divide it by 3. And that gives me a value of 0.4. For N2O4, I'm going to have its concentration will equal 0.96 divided by 3, which gives me 0.32 molar. Normally in a problem, I have some clues as to whether the reaction is going to go to the right or to the left, or which one loses, which one gains, which one gets minus, and which one gets pluses. With a problem like this, I have 2 choices. I can either figure out what Q is and decide which way it's going to go, or I can guess and it's probably going to be likely. I'm going to make this side minus and this side plus. Since I have a coefficient of 2, minus 2x, coefficient of 1 plus x. At equilibrium, 0.4 minus 2x, 0.32 plus x. And now I'm ready to plug these values into the equilibrium expression. So I have an equilibrium value of 0.5, and 0.5 will equal 0.32 plus x over the quantity over 0.4 minus 2x with that quantity squared. Now the bottom has to be FOILed, and I'm going to take that and then have to cross multiply and collect all the like terms until I go through the quadratic. So to begin with, I'm going to FOIL the bottom. .5 equals 0.32 plus x over 0.4 minus 2x times 0.4 minus 2x. Now I'm going to FOIL the bottom. So I'll have 0.5 equals 0.32 plus x over 0.16 minus a total of 1.6x plus 4x squared. And now I'm going to bring this across, so I have 0.5 times 0.16 minus 1.6x plus 4x squared equals 0.32 plus x. Distributing the 5, 0.08 minus 0.8x plus 2x squared equals 0.32 plus x. I'm going to collect like terms on one side of the equation. I have 2x squared minus 1.8x, 0.08 minus 0.32, negative 0.24 equals 0. Ready to go into the quadratic with a, b, and c. Negative b plus or minus the square root of b squared minus 4ac, the whole thing over 2a. Or 1.8 plus or minus the square root of 5.16 all over 4. And the square root of 5.16 is 2.27, so I'll have 1.8 plus or minus 2.27 all over 4. I'm going to get 2 roots here, one when I add and one when I subtract. Adding 1.8 plus 2.27, divide my answer by 4, gives me 1.02. My second root, 1.8 minus 2.27, all of it divided by 4 gives me negative 0.118. Okay, so I have two roots. I need to decide which one works. I can see that if I plug x1, 1.02, into here, I'm going to have 0.4 minus 2. That's going to end up negative, and I'm not allowed to have any negative concentrations at the end. So I can reject that root and choose this one. Now I'm going to take my correct root and plug it back in to get my equilibrium values. 0.4 minus 2 times negative 0.118 gives me a value of 0.636. 0.32 plus negative 0.118 gives me 0.202. I'm going to check by plugging back into my K expression to see how I did. K equals 0.202 over 0.636 squared. And I get 0.499, which is darn close to my K value of 0.5. And there's my answer. Or these are my answers.